Welcome, everybody. My name is Ramón. I've been working with LabVIEW for 8 years almost now. Mainly in firstly in the solutions with David helping me job when I didn't have much of a clue what I was doing, to be honest. So I've always been very grateful for that. There you go. Then I became a LabVIEW architect since 2022. I've been working with C# for a very short period of time, then Python and various as of late. And one of the things I've picked up since I started moving throughout my career is how biased my programming data flow, programming mindset is because of LabVIEW. So instead of being like a traditional software engineer that's worked with text-based languages before, my first contact with a programming language was LabVIEW. And therefore, when I had to start for the first time working in a text-based language, I realized that was a bit of a shock, basically. Today I will be talking to you about how basically your LabVIEW programming mindset can help you in starting programming a text-based language. I chose Python because everyone is kind of worldwide one of the most used software languages in the world. So it's kind of one of the most basic ones and scripted ones. At the moment, I do work in Evolito after moving to after moving in from Control Server Solutions and then Renshaw, and we developed electric motors for the aerospace industry together with MCU motor control units that are integrated to these electric power units for aerospace. We use lots of National Instruments hardware and software. Currently, it's only myself working as a full test NI engineer. Therefore, when it comes to building certain applications, people would rather me not programming in LabVIEW, mainly because when you show something in LabVIEW to somebody that hasn't seen it before, they're a bit shocked and it's like, oh no, please no. So today I will show you pretty much what the case scenario is and has been for a couple of certain times at my workplace, where basically someone comes and says, oh, I need a very simple PC-based application to just literally acquire some data from this 10 bench and then save it to a data file or to a database. And I always say LabVIEW. And sometimes people say no, please, because if you go away, you go on holiday, or this happens, or that happens, or for some reason you leave the company, then we do not know how to maintain that. So what I have to learn myself, and a bit with support from other resources, the internet, and other software engineers within my company, is kind of like learn how to code in a text-based language. So therefore, basically I can transfer my knowledge from LabVIEW into Python. So if any of you have ever been in this position,
sorry to interrupt from online. Are you sharing the screen? Or do you have slides up?
Yeah.
Okay. I don't think we can see it on the call.
Oh.
So I'm online and I can see the screen. Currently says, do not worry, today I will show you.
Yeah, that's right.
Okay, sorry, just me then.
Yeah, so if you've ever been in this position where you've been working for LabVIEW for such a long time that when you open or you've been asked to develop a program in or a software application, a text-based language, do not worry, I'm going to try to show you how, from a very user-friendly and basic perspective, translate that knowledge and mentality into a text-based set. So basically how the data flows in Python, from a LabVIEW perspective, how to create a GUI in Python, which is one of the front panel of LabVIEW, one of the main kind of selling points of LabVIEW, and then how to implement object-oriented programming in Python to then graphical user interface, and how can you take advantage as well of one of the main features of Python, which is virtual environments. So if you're this person when we get a presentation, then by the end of the presentation, hopefully you'll be more helpful, and if you ever want to give it a go yourself. So few of the requirements says it has to be zero cost. So LabVIEW, you cannot use LabVIEW, perhaps because maybe you have there's no resource to buy more licenses. It has to be shareable, so at least let's say in 2 or 3 PCs. And if you ever leave for whatever reason, because of your scenario or company, you're the only person that has LabVIEW knowledge. Therefore, if anything happens, so it needs further development or support, your colleagues need to be able to collaborate to maintain the application. So how does data flow in LabVIEW? Pretty sure we're all very familiar with this. I've kept it very simple. So you've got your inputs, you've got your VI or your function, and then they produce an output as long as the inputs meet. If you were to now say, okay, so how does this work in a text-based language? So if you were to turn that kind of very simple flow chart 90 degrees to the right, it will look something like this, which is kind of like it works on Python. So you've got your inputs there, which is your parameters, same as you have on LabVIEW. They hold your function determined by the def prefix, and then you return an output, in this case the calculation, and then you print your calculation to your terminal just to make sure it has done what you want it to do. And if you see the difference, basically it's kind of from left to right. It's a similar situation by going top to bottom. So if you, to break it down a bit more, if what is what, you've got constants, because they've got fixed value, then you've got your inputs that go into your function, you have to define it within the parentheses, and then if you want your function to return something, you need to specify the return within your function. And then you can just call your function as you wish, just by making sure you always has those 2 parameters that you defined previously when you defined the function. So if you, one of the main selling points of LabVIEW, as I mentioned before, is the fact that you can basically display this data very easily. You have always your front panel together with your block diagram. So if you ever wanted to, let's say, convert those 2 constants that we had before into controls, all you have to do is convert to control, and then you have it. You have 2 entry parameters and an output, which is your indicator. In Python, we do not have those. So if you were to, how do I get something similar to this? You have to build your or script your front panel. So you have to build your graphical user interface prior to defining your function and the functionality of your software application. So I will show you now how a basic user interface works and how all the quirks and very few details are to make sure that it works with the function and the functionality of your application. So in Python, you have to basically write your user interface. In difference to LabVIEW, where your user interface is already there, you just have to drag and drop the controls and properties. In here, your user interface, you have to say it is an object that you need to instantiate, and you need to give it certain properties. So it's like the title of the window, the width and height of what size of that front panel window that you want. And then you can give it parameters such as to type data. Those data entries, they do you, if you want that data to be updatable, it needs to hold a variable. And then if you want to display the data, you have like label entries, and those displays the functionality of your functions. There's a few other details to bear in mind, like for example, this between lines 12 and 16, this is a function that basically stops the user from entering digits that are not numeric characters. So you don't end up summing 8 plus 7, because it basically does not make sense. And then certain other, when we break it down from a LabVIEW perspective, you could say your parameters are basically your controls, your variables, your stored variable, your labels are your indicators. If your indicators have like a text, is literally the same as such as a label in LabVIEW in your front panel. But if your label is holding a variable in itself, then the value can also be updated. So moving on, one of the another few take points between LabVIEW and Python is the in Python geographical user interface is a library. So in order to make sure that you can develop your graphical user interface in your Python script, you need to make sure that your library is installed via the Python package manager, and that you always type the import your library and then ask to show the name of your function. There are plenty of libraries in Python, so there's so many of them, but it's always important to check that you have it installed before you attempt to do any functionality. Then on your left-hand side is how libraries look in LabVIEW. So this just classic right-click on your block diagram will display all your libraries with all your palettes, and it will display the functions of each library as you hover over each of the icons. So yeah, a few takeaways. Good thing about Python is if you don't like certain library or features of your graphical user interface, there's other ones. You've got, I use Tkinter because it's already installed by default, but you can use PyY, PyQt, there's plenty of them. The GUI requires development, which if you've been working on LabVIEW for a long time, it will put you off for a bit, quite a bit. I can show you what I kind of did to make it not as much of a hassle or pain to do. Just a quick thing as well, if the library uses functions that or variables that are within your software functionality, main software functionality, these needs to be declared before you build a script your front panel or front panel window, simply because Python is a scripting language. So if it goes to the line of the button, open button, and then open button calls this function, and this function has not been defined before, it will just throw an error saying, I don't know what it is. So it's something to, the flow is something to bear in mind. Another selling point of LabVIEW, I think, once you have your front panel and your laid out as you want to, say, okay, so one of the key advantages of LabVIEW, what it's very useful for, is to acquire data. We've got some sensors, some sorts of that, and I want to acquire some data from it. So how can I do that in Python, for example? So as before, there are like plenty of libraries to use in Python. So in this case, there is an example of a Modbus TCP temperature sensor. As before, you have to import your library, make sure it's installed. Then you instantiate the objects and say, I want to connect to this sensor with this IP address. At port is always 502 for TCP. And then you just define your functionality there for your, to basically the function that rates the temperature value of the sensor. And because the temperature value of the sensor is going to be, say, updated or tagged to your temperature value, your UI, you need to define your temperature value label prior to defining the functionality that's going to rate your sensor. And then at the very bottom, there's something that I realized after, that you need to tell the GUI in Python, the GUI library, to do not constantly poll you need to include that so it doesn't hold the UI from executing your read sensor, and it doesn't, so it updates accordingly. Just to refresh your minds, but obviously something very similar that we're liking in LabVIEW. This is much more simple to use, but if you haven't seen LabVIEW before, like something perhaps, as I mentioned before, some of your colleagues might be concerned about, oh, if something happens, so we want to improve the functionality of that. I don't know how. And then moving on, like before moving on with probably for me the biggest hassle was the object-oriented, the developing a graphical user interface, mainly because coming from LabVIEW and seeing how easy it is, coming into here, I thought it was a bit too much of a faff, to say it that way. So I thought if I have to type this every time I want to develop an application in Python, it's going to be quite tedious and it's going to put me off. So what I did is just a very simple example of object-oriented programming in Python, which is subject to the same principles as in LabVIEW, of course. So you can encapsulate your object, your graphical user interface object into a class of your own, and you can create like something very simple. So a few properties to set once the object is instantiated, like the dimensions and the title, and then you can insert a couple of parameters and your result or your label that's going to hold the result of your calculation. And then once you have that, all you have to do in your new application, your new script, you can just call that library, you can just instantiate the class, give it the properties that you want, pack the GUI and make sure it's drawn onto your front panel. And then as soon as you run these 4 lines, you basically do the same that all these 30 lines. So that makes sure that kind of it's much more easier and easier to get started with your new application or application development. Another very important thing, I think, or one of the best things probably about Python is virtual environments. Is the ability of like creating like a sandbox completely isolated from your global installation of Python on your machine. So I found this very powerful because you can combine different versions of Python in just applicable to your sandbox and combine it with different versions of your Python packages. So therefore, if you had an application that for whatever reason needs to use this version of a certain library to work with a specific piece of equipment, you can create a sandbox, install the Python version that works well with that library that you have, and then all you have to do is once you open your Python script is go to your script folder, call the activate, so your virtual environment is activated. And once you execute your script, it will execute with the Python version within your virtual environment. So why would you bother with this? So this is a very simple application that I did when I started working with this, which is basically I just gave to a few test engineers a very simple, so a very simple application to analyze data that basically just gets the results data from a TDMS file. It comes from a dynamometer test cell, and then you can choose your group. You can then choose your channels that you've put to that group in your TDMS file, and then you can calculate just a few basic parameters like what's the mean value, maximum value, and the minimum value of all that set of sample data within your TDMS. One of the things that I've realized with this, there's something that probably I would like to explore further. It's like I found that you struggle quite a bit to open big data files, Python, and it is slowed down the application a fair bit. So it's something that probably I would like to keep exploring and see how much fast they can be, considering how fast Python can be. So yeah, this is like a more example of an application that's basically has 0 cost. It doesn't use a library license. It has its own virtual environment. So if your colleague has Python installed in their PCs, you can give them the virtual environment, and it's completely isolated for the global Python setup. And it allows them to quickly visualize the data, perform some calculations, and automate a bit better their workflow. So based on what I've found, I would like to explore a bit further how basically how much more of LabVIEW kind of transfer into Python. So another key advantages or selling points of LabVIEW is the building concurrent processes. It's very easy in LabVIEW to just create another loop and then just create data from two different sensors in two different loops. It's very intuitive and very easy to see the data flow within LabVIEW. It'll be good to see how Python can handle that and what are the trade-offs for that. And then probably just QMH probably is the most known LabVIEW framework, and it would be. I'm curious to see if there's anything that can replicate that functionality as well, building, especially seeing how much you struggle to read big data files. My initial Python tool did. We'd like to see how by separating threads, I can speed up that process with the QMH. So I guess Nick is going to talk much more about this, but it was a good idea to basically just, I guess it changed well into the next of the meeting. But I think LabVIEW has evolved a lot into how it works with Python. So we went from just being able just to call a Python function and pretty much that's it. So now something that I think is quite powerful. I haven't had the chance myself to do yet, but it's to call virtual environments in Python from LabVIEW, which I think it can vastly expand the usability of your test application, and it can make it much more versatile. So wrapping up, hopefully today you have a bit more of an idea of how basically from a LabVIEW user, you can create something in Python that works similar as it does in LabVIEW, with a strong panel, acquiring data from a sensor, and basically how you can replicate the kind of selling points of LabVIEW, although with a bit of a pain initially. Also, you have your graphical user interface, which is probably the most tedious part to set up, especially at the beginning. But if you, with a bit of like basic object-oriented programming, you can create one, and then if you like to add something else, you can always create a child of that class and call it GUI version 2.0, and then you can call that into your main Python script. And then as soon as first thing that you have, once you run the Python script, you already have your front panel. And then hopefully you are being more confident if you haven't. This was a kind of confidence building exercise for me to start programming in Python or other text-based software language. Thank you for listening. And if you have any questions, I'm more happy to answer.
Okay, one question. Which IDE in the suite of, was it Anaconda? Which IDE did?
Oh, there's Visual Studio Code.
Oh, Visual Studio.
Yeah,
that's good.
So yes, I try to get as free source, open source as possible.
Not the moment.
Yeah, we go. Yes, Steve.
Yeah, Steve here. It's interesting that you're comparing LabVIEW and Python. One of the comments I would make is that if somebody wandered up and said, I want to read a data file, do a bit of maths on it, plot it on a graph. If I picked LabVIEW up, I could do that in possibly half an hour without too much trouble. If I had to do that in Python, it could well take me a whole morning, because you've got to get to grips with the Python language. You've got to understand Tkinter and how it works with user interfaces. There's another package, I can't quite remember what it's called, that does graphing. You have to know how to work with that, integrate the graph into your existing GUI, It's a long job. So from the company's point of view, if they just want something doing quickly, LabVIEW is the obvious choice, I would think.
Yeah, but yeah, I mean, I think as I mentioned previously, sometimes it's not just up to the company. I think sometimes it's hard to. For me at the moment, in my current company, I'm the only, it's called full-time systems engineer with LabVIEW knowledge.
Right.
So sometimes there are traditional software engineers that would prefer if it's written in a text-based language. For me, of course, if I had the choice, yes, I mean, absolutely, I could have done that or plotting some data, acquiring data from a Modbus sensor and so on much quicker in LabVIEW. But then if I have to do it in Python, I agree. I think the first time you do it is quite a pain. But I think with the use of object-oriented programming and encapsulating those functionalities onto classes, then you can reuse that functionality a couple of times. So second time that you come around to that situation, it's kind of, it should take you less time.
Yeah, maybe one of the other approaches you could take would be to see if you can encourage some of the other Python-based programmers to gain knowledge of LabVIEW, do some of the training courses which are free online, and become proficient in it.
Yeah, absolutely, I agree. it would take work off my workload, so that'd be great.
Yeah, because being the only LabVIEW developer is always hard because you run into problems. You want to discuss ways of doing things, and all the Python guys can sit and chat quite happily about it, and you're on your own. It's much easier if you've got other people there that you can bounce ideas off.
Yeah. Right.
You mentioned you use a lot of NI hardware. How do you find integrating Python with NI hardware?
I haven't done so yet. I know we use PXIs. I love PXIs.
Yeah.
So it's either LabVIEW real time or C++, and for me it's just C++. I'm gonna stay off that front day. In terms of, I think what I would like to explore more, I think would be more the virtual environment stuff, calling it from LabVIEW, something that I've not tried yet, but I could see, I don't know, probably Nick gives you a few hints into my kind of, daily job. Because I think one of the things about Python is like, there's so many libraries that you can use to do like a lot of things.